Hello, good day, guys. Thanks for joining me. Today, this is the Adobe Fikemba. I told you in this channel I'll teach you physics, chemistry, and biology, and we'll continue with chemistry. We'll continue where we stopped. Okay. So in chemistry, we're going to be looking at in chemistry we're going to be looking at the other separation technique um, we've not touched. So we're going to be looking at number one. So we're still dealing with separation technique. Okay. So we're going to be dealing with number one. We'll be dealing with separating funnel. We're also going to be dealing with precipitation in this video. And number three, we're also going to be dealing with magnetic separation. Okay. Magnetic separation. If you have not watched my previous video, chemistry part 1 till this time, I think this should be part 9 or so. Go and watch it so you can understand the breakdown of how I've been explaining all the various subtopics in this topic. Okay. So now, but before we look at this, what's it called? These separation techniques that I want to explain to you. You know, in the previous video, I told you we talked about crystallization. And we also talked about fractional crystallization. I told you that crystallization has to do with obtaining solids from a saturated solution. And a saturated solution is a solution that contains maximum solutes more than it can dissolve in a solvent. And so, when we looked at that, we also made mention of what we call fractional crystallization that has to do with separating or obtaining salts. Okay, obtaining salts that is having, or separating salts that is having different solubilities at different temperatures. Okay, that's fractional crystallization. And I also told you about recrystallization, that it has to do with choosing a solvent from which this salts to be obtained is soluble in it when it is hot or insoluble in it when it is cold. All of these are just summary. And also, if you look at these salts in question, before we begin to talk about this, I would like to give you an example of some salts that are obtained in a purer form and they contain water of crystallization. You need to understand that, okay? Water of crystallization. So, examples of salt with water of crystallization. Number one, we have copper 2 tetraoxosulfate 6 pentahydrate. Okay, this is copper 2 tetraoxosulfate. This is copper 2 tetra. Tetra is coming from this 4 oxygen. Okay, tetra is 4. Tetraoxosulfate 6. Then this 5 is penta. And this water of crystallization representing hydrates, showing the salt contains water. So we have another one again. We have another one such as magnesium tetraoxosulfate 6 heptahydrate. Can you see that now? We also have number 3, copper 2 trioxonitrate 5 trihydrate. These are examples of salts that contain water of crystallization. So we have copper 2 tetraoxosulfate 6 pentahydrate. We also have, let me just add one more, maybe iron 2 tetraoxosulfate 6 and what? Heptahydrate. So these are salts that contain water of crystallization. I hope you understand that. Okay? So good. So now we're going to be diving into this. Okay. I'd like you on the comment section to give me other examples of salts, okay, that contains water of crystallization. Write it down in the comment section for me. Now let's quickly look at these separation techniques we have here. Here we have what we call separating funnel. First of all, separating funnel separating funnel is used to do what? To separate a mixture that did not mix. Okay? It's used to separate solutions or mixtures of substances that do not mix, or two immiscible liquids, as the case may be. So that's what separating funnel is used for, to separate. Now, for example, in this case, separating fuel and water will be a very good example using the separating funnel. And the method of doing this will be by what? Decantation. What's decantation? Decantation is a form of separation that has to do with the more denser liquid will stay at the bottom of the container, while the less dense liquid will stay at the top. So in this case, let's say we have this mixture now, this solution. You'll see that fuel will stay at this top, while water will stay below. Why this fuel is representing a region, upper region of less dense mixture, why this one, substance rather, why this one is what? More denser, okay? And that represents water. So in the case of separating funnel, what is done is that when this thing has been poured in the container, the separating funnel looks somewhat like this, okay? Then around here, are you following me? Can you see? Good. Around here, you have a tap. Okay. Around there, you have a tap. Okay. Then this is the container. Now, in this case, you have a what? A less dense fuel at this top. Then you have a higher dense water at the bottom, having the formation of decantation process. You know, I told you decantation has to do with separation of insoluble solids from their solution, where those solid particles will stay at the bottom. Why? Because they are more denser, while the less dense will stay at the top. But in this case, the fuel will be at the top, water will be down. So when you open this tap, the water will begin to drop down into the water container. As it drops, what happens? This water will be separated, and then this thing, that's meaning the water will be tapped off, and then this tap will close, leaving only the fuel, which will now be poured into another container. So when you look at separating funnel, it's used to separate two immiscible liquids. Example is petrol and water. I hope with that is very clear. You can try it at home. Just get kerosene, pour it on water. You will see that the kerosene will always be found at the top of water. Take red oil, pour it on water. You see it. You cook, right? So I'm trying to make this chemistry a more realistic, practical one. Okay, the next one is precipitation. So I'm going to clean this space to just do that. I believe you have written this down. So what is precipitation? Now, precipitation is a kind of separation techniques that deals with separating a salt that is having different solubilities, okay, in two mixable liquids. Are you seeing it now? So precipitation, number one, precipitation. So we're looking at, I'll just put PPT as precipitation, okay? So precipitation number one, you must know it has to do with separating a salt, okay, that has what? That has, okay, different what? Solubilities, okay, in two mixable, take note, two mixable what? Liquids. Very important. These liquids are mixable, but these salts have different solubility in these two mixable liquids. Take for example now, you have ethanol and water. You know this ethanol and water, they are mixable. Is that also? They are mixable. And you know in the previous one of the separation technique, we explained how this can be separated. If you know in the comment section, write to me how ethanol and water can be separated. That's by the way. Now, but in this case, in the case of precipitation, the salt you want to separate has different solubilities in this mixable liquid. Now, for example, if you bring this salt, iron 2 tetraoxosulfate 6, this iron 2 tetraoxosulfate 6, iron 2 tetraoxosulfate 6 is soluble in water. So let me write it here, FeSO4. This iron 2 tetrasulfate 6 is soluble in water. Now, if I have this substance now, both that are soluble, if I'm going to separate this iron 2 tetrasulfate 6 from this water, all I need to do is to take ethanol and pour into this solution that already have this dissolved iron 2 tetrasulfate 6 in this water. So what will happen is that this ethanol will mix with the water and precipitate iron 2 tetrasulfate 6. That's why we say precipitation has to do with separating a salt that has different solubility in two mixable liquids. Do you understand it? If you understand it, say copy. Write copy in the comment section. So these liquids are mixable, but the iron 2 tetrasulfate 6 is soluble in water, but insoluble in this. So why this mix with this, it will precipitate this one out. Another this thing you want to analyze with another example you want to use in explaining precipitation is when you have let's say you have two substances, chemical substances reacting together to form a product. For example, you have, let's say you have silver triazonitrate 5 and sodium chloride. Let me write that. So I want to give another example of what precipitation also look like. So, but take note of this. This is very, very important. Okay. So another example of precipitation is the reaction of two chemical substances. You have sodium chloride, aqueous, reacting with silver triazonitrate 5, aqueous. Now, in this case, I'd like you to pay attention. Now, precipitation is said to take place here when these two chemical substances react together, these compounds. When they react together, they will form a soluble substance and an insoluble, they will form a soluble compound and an insoluble compound. So the soluble compound is already in the solution, okay? While the insoluble can be what? Separated by filtrating it. The insoluble will now form the residue. That residue that is formed is what you call the precipitate of the reaction between these substances. So precipitation can be seen here. For example, when sodium chloride reacts with silver triazonitrate 5, who can tell me? I'd like you to also comment right on the comment section why we say sodium chloride is aqueous and why we say silver triazonitrate 5 is aqueous. Write on the comment section what you think, why this is aqueous. So let's continue. So I've given you enough, questions for you to analyze. So I just like you. This video might be a little bit long, but don't be afraid. I just want to compress all of this. It's very simple. Follow it, you will enjoy and understand properly. So now, what is this now? So we have, sorry about this, okay? Sorry. So we have sodium chloride reacting with this. What does it give us? It will give us silver chloride, okay? Silver chloride will be formed plus what? Sodium triazonitrate 5. Let's see if the equation is balanced. Let's try and balance it. This is sodium is 1. Sodium is 1. Triazonitrate 5 here. Triazonitrate 5. Silver, chlorine. So it's balanced. Okay? So you have sodium chloride reacting with silver triazonitrate 5. This silver chloride is what? Is solid. This silver chloride is solid. While this one is what? Aqueous. Okay? So this guy is what? Insoluble. So obviously this silver chloride is the what? Is the precipitate from this reaction. Why this one is soluble? Do you see it now? So take note. This is a good example of a precipitate reaction. These two chemical compounds reacting together, sodium chloride aqueous and silver triazonitrate 5 aqueous. Go and find the reason why it is giving you silver chloride, which is insoluble. And now, if I ask you, how can I remove this insoluble substance from a solution of this mixture? So, a mixture of this solution. So, what do? I'm going to do what? Carry out filtration. On that filtration, silver chloride will be found on the filter paper, while these other ones will go through. So, that residue, that insoluble particle, because when you look at filtration, it has to do with the separation of insoluble solids from their solution. So since this is an insoluble solid, I'm going to separate it from this solution. Filtration will be the best option. Chemistry is something that you need to study all the time, okay? And if you do that continuously, it will be very easy for you. Don't forget, you can get A1 in chemistry, you can get A1 in biology or physics. Start now and start early. Okay, so this is what this thing look like. The last one before we call this thing a day is magnetic separation. Number 3, magnetic separation is used to separate magnetic substance from non-magnetic substance. Do you understand? It's as simple and straightforward as that. Magnetic separation is used to separate magnetic substance from non-magnetic substance. Example is the separation of ion filings and sulfur. Ion filings and sulfur. Or another example is the separation of impurities from tin ores. Separation of what? Impurities from tin ores. So magnetic separation is separating magnetic substances from non-magnetic substances. Sulfur is non-magnetic. Ion filings is what? Magnetic. So separation of impurities from tin ores. Okay? So when you do that, you are already carrying out magnetic separation. I hope you do enjoy the class. If you're not following me, follow me. Forget about the length of the video. It will help you. Thank you. See you in the next class.